Okay. One of the labs for density, you're going to use, in the baggie, you had all kinds of different objects. Some of these are different in yours. I took what I had, okay? What you're going to do is we want the density for a variety of different materials, different objects, okay? Like if you use a penny, don't put one penny in, use several pennies, okay? So first thing is figure out what items you want. You're going to make a table. In the table, you're going to have the item. Don't write something like heavy thing. It's a fishing lure, okay? Wine cork, die. A cube is fine, okay? There's a washer. There's a couple washers. These are nails. There's a marble, etc., okay? What you're trying to do, you need the density. So obviously we're going to weigh each one. We need the mass, but we also need the volume because density is the mass divided by the volume, just like you did with your bowling ball, okay? Now, some of the objects will fit inside here, inside your graduated cylinder. Not so much that, but you might have a smaller one that does fit. The fishing lure, which is irregular, the volume can only be determined by dropping it in water and seeing how much the water rises. Same thing with a bouncy ball, etc. Some of the objects, you can only measure the volume by displacement, meaning, like this is a 50 mil, you would put in, let's say, 25 milliliters of water. You would then take, if this fit, yours might fit yours, drop it in and see how much it raises the volume. The difference is the volume of the object. Think Archimedes. Some objects, like if you have a marble or a small ball, you can actually use the formula, the formula for the volume of a sphere, okay? And measure the volume directly. Same thing as with your cube. You have a protractor in your kit. Notice you have metric measures right here if you do not have a ruler that has metric measures, okay? You can calculate the volume of the cube, length times width times height, by measuring directly. You can also, what's the volume by displacement, okay? Remember now, volume, if you measure it directly, is going to be in cubic centimeters because a cubic centimeter is equivalent to a milliliter. So if you have your answer in millimeters, because you're being very precise, great. However, you must have this in cubic centimeters so that we can compare it with the volume here. So if you can just get a data table that has the object, mass, volume, density, we'll work on, again, taking everybody's information and trying to we'll try to put it together and then show you how to do percent error and then to evaluate which method do you think is more accurate.